Hey there, future innovators. Today, we're diving into something super common but with a twist: water bottles. You probably used one today, but have you ever stopped to think what's just happens to this thing after you're done with it? Hmm. Well, in the United States alone, we use more than 50 billion plastic water bottles every year. That's about 150 bottles per person. That means the average person uses and throws away one of these about once every 2 days. And most of them, they're used just once. Many of those bottles aren't recycled. Instead, they end up in landfills, rivers, and oceans, where they can sit for hundreds of years. Yet, compared to the average human lifespan, plastic just doesn't really go away. Animals mistake that plastic for food, and it can hurt them or even kill them. Plastic in the ocean breaks into tiny pieces called microplastics that end up in fish, birds, and sometimes even us. Not to mention the big pieces of plastic, like this plastic rings that hold together water bottles, not unlike this one right here, can sometimes end up constricting the airways of sea creatures or wrapping around developing sea turtles like we see in this picture, leading to a malformed adult sea turtle. Here's where you come in though. What if we could design a better kind of bottle? Just a cooler bottle, one that keeps our drinks cool, is easy to carry, maybe it doesn't hurt the planet, especially. Well, before we start thinking about how we would design something like that, let's think about what makes a water bottle awesome, or what kind of qualities we would have in our perfect water bottle, in the water bottle that we would want to create. Well, I know I would want to make mine that keeps things cold or hot for sure, because that's really useful. Also, it can't leak. It's not really useful if it leaks. It's got to be durable too, because if it's not durable, then we'll just end up having to throw it away pretty soon after we make it. Kind of like our plastic water bottles. It's got to be light and easy to carry, of course. And if all those other things are true, it'll be good for the environment because we won't have to throw it away. But before we can talk about one of the most important parts of that, keeping the water bottle cold or hot, let's think about what is cold or hot? What is temperature? Well, according to scientific theory, temperature is a way to measure how fast the tiny particles in something are moving. Now, you might remember when we learned about particles that all matter, everything around you is made up of these tiny things called particles. Even your water in your water bottle. When something is hot, its particles are moving fast. And when it's cold, the particles are moving slowly. So when we say a drink is warm or cold, we're really talking about the speed of the particles inside it. When we put a cold drink in a warm room, the heat from the room tries to make the particles in your drink move faster. That's why your ice water eventually turns warm. In a similar way, when you have some hot chocolate and you take it outside to enjoy it on a snowy day, the cold air particles around your hot chocolate are moving faster as they take away heat energy from your delicious cocoa. The air starts out slower than your hot chocolate, but the air particles around your hot chocolate move faster and faster, and they take away that heat energy from it. So whether you want your water to stay cold in your water bottle on a hot day, or you want your hot cocoa to stay warm in your bottle on a cold day, the trick is to keep heat in or to keep the heat out. Well, that's where conductors and insulators come in. But what are conductors and insulators? A conductor is a material that lets heat move through it easily. Think about a metal spoon sitting in some hot soup. The spoon heats up quickly because metal is a good conductor of heat. But that's not great if you're trying to keep your water cold, right? Now, an insulator is the opposite. It's a material that slows down heat. Foam, plastic, rubber, and even some types of fabric are insulators. That's why your winter jacket is filled with insulating material. It keeps the heat in. So when we're designing our water bottles, we want to use insulators or things that insulate well as opposed to conductors, things that conduct heat well. If you want to keep our drinks cold and prevent heat from escaping or the heat from getting in to our water bottle. Now, some people have thought of the idea of using bottles with 2 layers of metal and a vacuum between them. That's called vacuum insulation, and it's one of the best ways to stop heat from moving in or out. Pretty cool, right? Your mission is to design a better water bottle. You'll test materials, think about how heat moves, and try to build something that really works and helps the planet too. This project is real science and real engineering, just like people design safer cars or better backpacks, or more environmentally friendly straws like these metal straws, or more environmentally friendly grocery bags like this fabric grocery bag that's not made out of plastic. You can design a bottle that helps the planet. Now that we've seen the problem and the challenge, it's time to get to work. Over the next few weeks, we'll be following the 5E learning model to guide our thinking and designing. Here's what that looks like. First, we have engage, the first of the 5Es. That's what we're doing right now. You're getting curious, asking questions, and learning about the challenge of single-use bottles. Explore. We'll test different materials to see how they hold heat or cold. You'll run experiments to discover what works and what doesn't work. Explain. After we collect the data from the explore phase, we'll make sense of it together. In the explain phase, we'll talk about conductors, insulators, how temperature really works, more in depth. Elaborate. Then we're going to go into the real design and working. That's when we'll sketch, build, and improve our own bottle ideas based on what we've learned. Finally, evaluate. This is when we'll test and share our designs. We'll see how our bottle performs and reflect on our thinking and how it's grown. You'll be working like real scientists on this project. And you'll be working like real engineers as well. You'll be asking questions, testing ideas, and creating something that could make a difference in the real world. I can't wait to see what you come up with.